Oh,
No, but then he moves out of the camera.
yeah.
That's the
I
problem.
have to stand in.
You know.
Am I good to go? Okay. Tonight, our speaker is Dr. Matthew Szydagis. I get that right?
Szydagis.
Yes. And, you know, he was kind enough to travel through this brutal weather to get here, 4.5 hours from the snow-covered Albany and ice. And so, thank you so much. He's a member of the physics faculty at the University at Albany, SUNY. He does research in experimental particle astrophysics. He's a member of UAPx, a network of individuals using scientific methods to explain UAPs, UFOs. And you've probably seen him on the History Channel series, The Proof is Out There. And he's been in the award-winning documentary, A Tear in the Sky. So, and what's very significant and quite evident behind me is he's been a fan of Star Trek forever. So, anyway, please welcome Matthew Szydagis.
Thank you, everyone. Thanks for having me tonight, and for asking me to talk about actually an unusual topic. It's not every day you talk about UFOs and aliens to an astronomy group, but really this is going to be from a very rational and quantitative perspective on what do the facts say about what the different possibilities are. And so today's talk was also, even though I'm the speaker, I give co-author credit to my friend Kevin, Professor Kevin Knuth, who really got me associated with this craziness. I'm surprised that I wasn't invited to talk about my dark matter research. Maybe another time that's more mainstream astronomy. And I also want to thank Bob Ney for sharing his own talk slides with me, for which I borrowed very liberally. Here's a picture of him in the museum in Roswell. And I also wanted to say before I begin to dedicate today's talk to my mom. That's not an in memoriam. She's still with us. She's celebrating her 80th birthday today. No picture shown because she hates having her picture taken. So the first thing I'm going to jump right into is the study of exoplanets. So some of us still, debate whether we have 8 or 9 planets. Is Pluto, we talk about whether Pluto is a planet or not. And my opinion on that is, who cares? There are thousands of known planets, and we don't teach that. We don't teach that at the elementary or middle school levels or even at the college level. And so most people in the country and in the world still think there are 8 or 9 planets when there are several thousand of which we are aware. I believe we've crossed 10,000 candidates already, over 5,000 confirmed. This is already out of date from when I put my talk slides together. And this isn't 1947 anymore, which is pre-Sputnik by 10 years. We have to revise our prior assumptions that caused us to ridicule the idea of aliens and alien visitation as nonsensical. But some of the assumptions that went into that ridicule are extremely invalid now, because we know of, as I said, thousands of planets, except it's much more than that. It's thousands of planets in a tiny fraction of the sky. If we extrapolate that to our galaxy, which has over 200 billion stars, there are probably trillions of planets out there. There are probably more planets than there are dollars in the federal national deficit. Like, there are a lot of planets out there, and our best estimate is about 20% are habitable by the human definition of habitability. So it means go out in the sky. If we go out in the sky tonight, pick 5 stars. Odds are good that one of those 5 stars has a planet in orbit around it that's in the habitable zone, which means it might have liquid water. Maybe it has oxygen. Maybe it has these other things. So that's pretty high. So even if these numbers are off by huge amounts, there's still a lot of potentially habitable worlds. And that's only by the human definition of habitability. That doesn't account, as Spock would say, life. It's life, Captain, but not as we know it. So organic molecules have been detected everywhere. What does this all mean? It means that the idea of extraterrestrial life is a rational, reasonable, and justifiable hypothesis that should be seriously considered by the scientific community. There are alternative ideas for where a non-human intelligence could come from: extra dimensions, parallel universes. There's no evidence for any of this. Zip, bupkis. Bupkis, I missed that word. And similarly, there's also the idea that maybe, we're being visited in flying saucers by future humans. This has even less evidence. As much as a fan I am of Back to the Future, there are worse scientific criticisms of this than the suggestion of extraterrestrial life. There's also the so-called Wakanda hypothesis that present-day advanced humans are somehow hiding in plain sight. But again, all of these things are a lot more speculative than the idea of non-human intelligences that are from elsewhere in our galaxy. So my current thinking is that the ET hypothesis right now presents the most scientific grounding in terms of evidence to explain some fraction of what we call UFOs or UAPs, maybe a tiny fraction. The vast majority, of course, are misidentifications, hoaxes, and things like that. But I want to convince you that there is a non-zero chance that some very, very small percentage could actually represent something like probes from other civilizations. The ET hypothesis has the fewest flaws of all the speculative ideas, in my scientific opinion. And this also doesn't mean that all so-called true UFOs, if there is such a thing, correspond to one single thing. That's not what I'm saying, because classification is not binary. You can say something's a bird. What type of bird is it? And you can go deeper into that. And the whole point about the scientific process is we should be allowed to test exotic hypotheses. So an example of how your paradigm influences your data comes from my colleague Kevin. So I'm sure, if you're amateur astronomers, you probably know the story of the geocentric Ptolemaic view of the solar system versus heliocentrism with Copernicus and Galileo. And I'm going to tell you a little story that my friend Kevin came up with, which is, imagine a universe in which we were more advanced in optics. This is not that crazy to suggest that we were much more advanced in medieval times or the Middle Ages, for example, in Europe, with our technology with optics. And let's say Michelson and Morley did their famous experiment from the 1890s, right when we were debating geocentrism versus heliocentrism, and demonstrated no variation in the speed of light. That would have been interpreted as, aha, Copernicus is wrong, the Earth doesn't move. We proved it with optics, because we were centuries away from understanding the constancy of the speed of light. So this is an example of how you can have a cognitive bias based on the current scientific paradigm, where data you think data is data. It can speak for itself, but any set of data you have, you always plug it in to your current paradigm. So why do I think that some tiny fraction of UFOs might represent something extraordinary? Well, my colleague, Professor Kevin Knuth, here has a paper which he co-authored with a couple individuals, Robert Powell and Peter Reale from Scientific Coalition for UAP Studies, where he calculated the velocities and accelerations from several cases where there was more than just eyewitness testimony, but radar data and things like that, and showed velocities and accelerations that are not possible with human technology. And it's not just that it would liquefy, an organic being like us, but no material that is known to human size could withstand some of these velocities and accelerations calculated. Even if Kevin's calculations are off by a factor of 10 or even 100, they're still remarkable numbers in some of these cases, like the so-called 2004 Nimitz encounter, which you may be familiar with, where some naval pilots, where this is just one story of many, where they encountered a craft they couldn't identify that was executing some kind of extraordinary maneuvers. So this is not new, though. So Herman Oberth said the following in the 1950s. So if you don't know who Herman Oberth is, many people probably do in this audience, but he was a rocketry pioneer and mentor to Wernher von Braun. And he said this, and this is more than half a century ago, and this is a hard-nosed quantitative scientist. He said, but if we establish the working hypothesis that UFOs are machines, we also have to assume the following: they are not built by human beings, they are flying by means of artificial fields of gravity, they produce high tension electric charges. I mean, this sounds like science fiction, right? Like Close Encounters of the Third Kind from 1970s. This is the 1950s, and Oberth was referring to also radar objects going do that with today's technology even. And I highlighted the word electric because one of those stories here is about vehicles being allegedly affected by UFOs, and if that's true, that screams some sort, when you combine that by itself, that could still mean some kind of naturally occurring electrical phenomenon, but when you combine it with the high velocities and acceleration and high luminosity, that seems to suggest some sort of technology. And this is a quote from Kevin, my friend Kevin Knuth, in his paper. The observed flight characteristics of these craft are consistent with the flight characteristics required for interstellar travel. If these observed accelerations were sustainable in space, then these craft could easily reach relativistic speeds within a matter of minutes, hours, and cover interstellar distances in a matter of days to weeks. UFO or UAP, which just means unknown, is often conflated with aliens. They're not synonymous. But why does that conflation happen? Because data that supports that, at least in some very rare cases, there are incredible speeds and accelerations that involve seem possible even with current human technology. But there are many criticisms, such as why no good pictures? Well, this is a right, and Elon Musk tweeted something like this: camera resolution improves and UFO picture resolution stays flat. A UFO, quick, the worst camera we own. You know, that's kind of not very fair criticism, because technology's been improving, and I don't think we have any better pictures of atoms than we got in the 80s, late 80s. Kind of didn't get better at that. So everyone believes atoms exist. We don't have any pictures of nuclei, protons, quarks. So this is a little bit of an unfair criticism. There may also be something that's intrinsically fuzzy, and also phones don't make everyone photo experts. You know, if I go to imagine you are surprised before, also why do UFOs only occur in the U.S.? This is so not true that it's mind-blowing sometimes, the willful ignorance I've encountered. This was actually stated by a prominent astrophysicist, even though we've got, Mexico, Brazil, China's forming its own task force, and the French, this is 25 years ago, had a report. This is not some random French UFO organization. These are official, reports that, and you see here that in 1999, the French already said, yeah, it's probably aliens. This is 25 years ago, and yet we still laugh. It's amazing. That was an official report, and there was another report from the French government a couple years ago. But the point is, even if they didn't have that sentence in the report, that's not important. What's important is the claim that UFOs occur only in the U.S. is really, really not accurate. And there's the famous incident in Africa at the Ariel School, where students had these drawings. Now they stand by their stories as adults that they saw something land and creatures come out, and we laugh at their drawings, but we celebrate, for example, Galileo's drawings as real science, but we recoil at any UFO drawings. Nobody ever says, "Oh, I don't believe Galileo discovered the moons of Jupiter." That's eyewitness testimony. He wrote that down looking through a telescope. He didn't prove it. Where's the camera recording Galileo? So, and yet we balk at other examples of testimony and drawings. Here is Galileo's picture of the 4 Galilean moons of Jupiter. Now, is interstellar travel way too hard? Always comes up, though, as a very important question. We all know, especially amateur astronomers will know, how the long distances are there and something we cannot ignore, and long times correspondingly. How do you shield against radiation? What kind of source of fuel or energy would you need? But assuming primitive chemical rockets are the only way to travel through space is the equivalent, I would argue, of assuming only sailboats are possible on the ocean. This may be a failure of our imagination, actually, but we don't even need to speculate that far. There are examples of space of nomads on Earth, the Pacific Islanders, and my colleague Kevin suggests the possibility of space-time nomads. So the answer to the large-scale distances and the times are something that every single scientist seems to always forget. Whenever the topic of aliens comes up, it's almost like they forgot physics and that they went to school. It's just remarkable. And so people like Neil deGrasse Tyson just pretend relativity doesn't exist when they're arguing against the possibility of alien space travel. And so relativity actually helps you with time dilation and length contraction. So a homework problem I often give my students when I'm teaching, this is sophomores. This is not advanced physics. This is just for sophomore. This is at the sophomore/junior level. Is when we're learning relativity, I ask, how long does it take to get the Andromeda Galaxy? I think if I asked people in this room, you'd probably say 2 million years. That's actually not true. If I traveled 0.1 meter per second slower than the speed of light, it would take me 50 years to get to Andromeda. And that's not hypothesis, that's scientific fact. We use relativistic time dilation every single day. GPS wouldn't work without it. And so relativistic time dilation helps the traveler. Time slows down. So you can make it to the Andromeda Galaxy in 50 years, going fast enough. Of course, everyone on Earth that you've ever known is dead and long gone, and 2 million years will have elapsed on Earth. But who cares if you can explore the universe? So it is a common complaint that there is long distances that cannot be traversed because there's no such thing as faster than light travel. But guess what? You don't need faster than light travel. It's icing on the cake. You only need faster than light travel if you want to go back home. If you don't care, if there's no home, if you become nomadic, then faster than light travel might be a hindrance instead of a help. Counterintuitive. So you don't need faster than light travel. And of course, for relativistic travel slower than light, you still would need new fuels and new shielding. We'd need to discover new things. But we used to have similar complaints against air travel and space travel. 2 weeks before Wilbur and Orville's first flight, the New York Times had an article saying that it would take humans several million years to figure out airplanes. I mean, look it up. This is a historical fact. And because all newspapers are archived, New York Times can't escape this. Similarly, they wrote in the 1920s, some moron wrote an editorial that said rockets will never work because, quote, there's nothing to push against in space. Some idiot who didn't understand momentum, right? And like clearly, those are the kinds of people who are probably students who get like an F in my class, and then they go on to write new editorials in the New York Times that make no sense. And so we've been here before. We've said air travel is impossible. We've said space travel is impossible to just nearby. So why couldn't a civilization that's thousands, millions, or maybe even billions of years more advanced than us have figured this out? And as I said, what's really great is you don't even need to go faster than light. Not necessary. Icing on the cake. Icing on the cake, completely unnecessary. So here's, by the way, a clip, New York Times, 1903, flying machines which do not fly, and went on to talk about that, how airplanes will either never exist or it'll take a few million years for humans to figure it out. And then here's a quote from Sir Richard van der Reed Woolley in 1956, an astronomer who said all this talk about space travel is utter bilge, really. That was a couple weeks before Sputnik, or a year before Sputnik. Now, another criticism you often hear, if there's some sort of association between UFOs and aliens, I'm not claiming there is a one-to-one association because U simply means unidentified. William Shatner, great scientist that he is, knows what he's talking about, right? No, not really. He said UFO hearings were ridiculous because aliens wouldn't play hide and seek. Except he should know he was on Star Trek. They might have a prime directive type thing. Our society might collapse and advanced civilization would know that. And there are many science fiction stories that explore this, and they're fictional, but they're based on real ideas and research by psychologists and anthropologists. Think about there are several scary scenarios. Imagine if we make first contact and we ask aliens, do they believe in God? And they're like, oh yeah, sure. And then they describe their religion, and it matches one Earth religion, but none of the others. What would happen to the other religions? Think of terrorism on a massive scale, chaos. Oh no, they're from the devil. They're evil. How can they say the other religions are wrong and ours right? Like, think about the chaos that would ensue. And also the technological, social, and moral development stagnation. Imagine if Arthur C. Clarke thought about this possibility. So some advanced civilization appears. Why bother doing science anymore? Arthur C. Clarke explored this in Childhood Zen. Everything's done already. It's solved. Why would I continue in my day job to look for dark matter? Oh, the aliens already found it billions of years ago. They know exactly what dark matter is, dark energy. They've solved all the mysteries of the universe. Oh, and diseases? Oh, yeah, there's a cure for cancer, HIV, COVID, everything. Because it's trivial. They solved disease billions of years before humans even existed. Could humanity withstand the boredom of that? There's nothing left to do? I'm not so sure. That's a question not for me, but for social scientists to answer. But think about this: if an admission of the existence of any form of non-human intelligence, not necessarily extraterrestrial, would mean that, for example, the President of the United States would have to say, well, the Air Force cannot defend our airspace, nor the Navy the sea against some threat. And to quote Bill Murray from Ghostbusters, when he was talking to the mayor of New York City, describing the apocalyptic thing that was happening with ghosts, it's like cats and dogs living together. There's this great scene in Ghostbusters. Actually, it might have been Ghostbusters 2. Whatever. We're not mature enough for official first contact, but if there is anybody out there, they might be repelled by our culture. Think of all the isms and general unkindness we still have. There's always the zoo hypothesis, which may solve the so-called Fermi paradox, which is, where is everybody? The galaxy should be teeming with life. And Fermi claimed that before knowing about all the exoplanets. It was decades ago. I crossed out the word paradox though, because there's so many solutions to the Fermi paradox that's not really a paradox, because even though I said interstellar travel is possible, that does not mean it's easy and that every civilization will have it and that we're just like teeming with ships everywhere. So nowadays though, I don't think anyone would care or believe. President Biden could get up there and say, hey everybody, aliens are real, and it's like, nice with pictures and everything, nice CGI. We've got real problems to deal with. We don't have time for I'm actually more the social scientists say that society will collapse. I actually think nobody would believe it. And then conspiracy theories would form that are the opposite of UFO conspiracies. The conspiracy theories would form about their aliens aren't real, they're making this up to distract us from the economy. That's what I think would happen. But there's also the hypothesis of collapse and chaos. But I don't know which would be better. Now, another question you always hear is, why do UFOs, have lights? You don't need navigation lights in space. But the answer could be that this could be some sort of propulsion side effect. If we are talking about advanced craft, I'm not claiming that that's been substantiated, but maybe we're talking about some sort of side effect of Doppler shifting or something like that, and it's not really what we think of as navigation lights. And we also may be anthropomorphizing, of some beings that are nothing like us. It's like the ants in your garden trying to figure out, what are these giants clomping around? What are they up to? So you've all probably are very familiar with Carl Sagan, who would throw all of this out and just say extraordinary claims require extraordinary evidence. But there's some problems with this. So given some of the facts I've shown, like the huge amount of exoplanets, remember, it's not really thousands. That's one part of the sky. It's actually trillions, probably. And so I would say the claim we are alone is extraordinary. So I'm going to turn this around on its head. And so I think if you claim we are alone in the universe, that, in my opinion, is an extraordinary claim. Where is your extraordinary evidence of that? The evidence all points the other way currently. Now, space travel is impossible, you would say then, you would fall back on. But I would say that's also extraordinary, with all current evidence pointing that we should be able to extrapolate to be able to imagine better and better space travel as the technological society advances. Now, who gets also to define the word extraordinary? Germs, atoms, meteors, and the constant speed of light all used to be considered nonsense. All of it Okay, people used to die because of this. They still do. But doctors used to make a point, would say they would go from an autopsy to delivering a baby without washing their hands, because they say, I'm going to prove there's no such thing as germs, because it's nonsense. These are historical truths. These are historical facts. Atoms, they were laughed at. Meteors, rocks fall from the sky. You must be crazy. Lock that guy up. Rocks don't fall from the sky. That's insane. And so these are examples, and we don't learn our lesson as humans. We still don't learn the lessons of history, and we still make fun of new ideas. And does anyone ever go back and apologize to the people? Be like, oh, sorry, you weren't crazy. Rocks do fall from the sky. It's kind of hard to when the witnesses have been dead hundreds and thousands of years. In the case of meteors, rocks falling from the sky have been reported for thousands of years. Now, also, how do you find any evidence without money? So, Professor Avi Loeb of Harvard University likes to say that extraordinary claims require extraordinary funding. You're not going to find anything unless you actually have the funding to get the resources, to get the equipment and the students to do the research. So it's no surprise there's no solid evidence of anything about UFOs or UAPs or whatever you want to call them, because you're not allowed to study them. You're not allowed to go get any evidence. So really, Carl Sagan's famous utterance is really not a new idea, because it goes back to Hume's dictum, and even earlier, of course, to Occam's razor. I love this cartoon, Occam choosing a razor, and I have the same problem. Like it's so complicated, right? There's all these different technologies. So how do we evaluate this concept? How successful has it been historically? Well, the periodic table and the standard model of particle physics are way more complicated than just saying everything's made of earth, air, fire, water, and ether. That sounds a lot simpler to me. Doesn't that mean that should be right? But it's not. So what happened? And so Occam's razor is often misused and abused in the same way as Sagan's edict. You must have a model that matches the data. So it's not enough to say that you have the simplest possible model. It's got to be the simplest possible model that still matches the data. All available data, not just your cherry picking of the data you like. So my friend Kevin, who does Bayesian data analysis, would say that when you're calculating the prior or a probability of something, the sensor data are almost always going to be more probable. And so you lock yourself out of a discovery by just saying, well, the sensor data being wrong is just more probable than a new discovery. Now, you may have heard this question before, so why don't pilots see UFOs? Well, they do, and astronomers do too, but they're afraid to admit it because of the stigma. The reporting system, and this was mentioned in recent congressional hearings. There's a taboo. You're not going to report something because people are going to laugh at you, and then you'll show up in the office and there will be paper mache little green men and stuff like that. So nobody wants to admit they've seen something they don't understand, even though curiosity and discovering and looking at things you don't understand initially, that's what drives science forward. If they are out there, as I say, might be possible, why hasn't SETI worked yet? Partially, we're not mature for first contact. So let's putting aside any claims of all the way here. Let's talk about the galaxy again in general. Well, they may not want to talk to us yet, as I said earlier. We may also need to look for dead civilizations, look for artifacts, not just listen for radio signals, but also radio signals might be brief and replaced by something much better. Now, there in Star Trek, there's the subspace radio. That's fiction, but it's not too hard to imagine there's something superior to electromagnetic radiation that advanced civilizations would use. And the galaxy is an enormous. We may not be looking at the right frequency bands or the right technologies, which is a long-standing SETI critique. Now, I support SETI, but it should be part of a much better portfolio and palette. And I also think that I would wish that this goes back to Sagan community laughing at the UFO. ground that could be found here. Now, here's a parable, though, again, I support SETI, but it's still a fun parable of just a fictional story, just a parable. But I came across this online a couple years ago, the story of the Pacific Islanders, whom I mentioned earlier they're as being very nomadic and a good analogy for potential space-time nomads. But there was this story that Pacific Islanders wanted to figure out whether they were alone in the universe. So they sent up smoke signals and didn't see smoke signals from the surrounding islands and concluded they were alone in the universe. So maybe our radio signals are as primitive as smoke signals. So if we do make first contact someday, we'll be like, oh, radio, oh, you guys are so cute. Oh, radio, our infants play with radio, They'll say, like, who knows? There could be ways of communication that are superior that we have not invented. So there's this also, if aliens so advanced, why do they crash so often? This actually came up in the congressional hearings, and this one bothers me too, to the point where I'm a lot more ready to believe there might be some probe flying in the sky versus they crash, right? I am still much more skeptical of this than I am of the other claims, but there's still some reasonable things that can be said here. E.T., if they are real, may be foul flesh and blood beings, just like us, not used to atmospheric flight. And I actually think the true number of crashes is probably grossly exaggerated, if there is such a thing. I'm really skeptical. There have been like 50 crashes, and we have bodies and all this. It doesn't seem very probable to me. But my friend Kevin Knuth jokes that there's somewhere in some distant alien world black, and it says lives lost on Sol 3, or whatever they call Earth. So, why is there new one criticism always, I've lobbied myself against the concept of these crash retrieval programs is why haven't we reverse engineered anything yet then? Well, it's difficult. So I don't think that's a fair criticism. I still am very this whole crash business, but imagine I took your laptop and I gave it to James Clerk Maxwell, okay, or to Michael Faraday. I mean, Avi Loeb talks about giving a cell phone to a caveman. This is nowhere near as bad. Or, okay, give your laptop to Albert Einstein, although that's a bad example, because most people don't realize he was a theorist, non-experimentalist. There's a dichotomy there. But makes you feel better, say, give your laptop to Einstein. But the point is, all of these individuals, Einstein included, I would argue, for making any progress with your laptop. Once the battery died and there was nothing to plug it into in the wall, well, Einstein would have that, but not Faraday or Maxwell, they would make even less progress, right? They wouldn't even have the tools to determine the material composition. They wouldn't be able to make heads or tails of your iPhone or your Android or your laptop or your iPad. That there's a civilization that's billions of years old. Since our galaxy is billions of years old, the universe is about 13.8 billion years old. Imagine a civilization that's been around for millions or billions of more years. How could we even begin to make heads or tails of something? And so there's also indirect evidence. This wasn't front page news. It just disappeared. There was this Brigalia, I've not badgering the Pentagon and government agencies with FOIA requests saying, where is what kind of technology you reverse engineered from UFOs off and put off? And then finally they responded and gave them a bunch of documents on like cloaking technology and this, that, and it's like, okay, they didn't admit it was aliens, but it's kind of like pleading the Fifth Amendment, isn't it? But you don't have to say it because you plead the Fifth Amendment. And they didn't say, oh, here's our alien tech. They didn't say that outright, but they gave them a bunch of PDFs on technology in response to a very specific request. And that's very, very odd. I still think though, we're not making progress, even though that was the claim there on that point. I think part of the issue is if there was some sort of program like this, I'm really not convinced there is. You don't have enough people on the problem. You need a Manhattan Project, huge style thing to make any progress. Now, what about man-made black ops? This goes back to the so-called hypothesis. So in this scenario, we consider that there's black ops U.S. craft that has very strange capabilities. But no American pilots have come forward, and it's really crazy. You got all kinds of crackpots coming forward, and nobody comes forward and says, "Yeah, I flew that UFO that day." It's strange, And then we've got the claim that it's Russian or Chinese. And in my opinion, that's just laughable, and Sean Kirkpatrick, former head of the Aero Department, has done that. I mean, that's laughable. If Russia had this technology, why is it taking them multiple years to take over Ukraine? Why didn't they crush them overnight? China, they could just take over Taiwan. We wake up tomorrow and be like, oh, China took over Taiwan. If they had the kind of technology that we've seen in some of these alleged encounters. So it doesn't seem to really why would we also, the U.S., mess so badly with our own pilots? We have, 2 tiers of pilots, and then the good pilots, and then the even gooder pilots who are on the never appear, come forward. Why did we lose Vietnam and Afghanistan? Why have we not won a war in decades if we have this technology? What are we waiting for? It just doesn't make logical sense. And again, with Russia, the UFOs are not clearly, outdated attack held together with duct tape, like the space station Mir was. Like, it just doesn't make sense. Also, in some of the encounters, like the 2004 one with the so-called tic-tac shaped object, it jammed our radar, and that's an act of war. Who would risk a war with the United States that openly, a nuclear? So this seems very, very bizarre, and sightings also go back decades, if not centuries, when we didn't have, China was recovering, had a civil war, and was taken over by Japan, and then Russia was wounds from World War II, and we had, all the cases in that era. So it's very, very bizarre to explain away strange sightings with high speeds and things like that by placing the blame on U.S. adversaries. A viable explanation. Now, we've all heard eyewitnesses are not reliable, and this is true. Now, there's this famous study. Now, who here, show of hands, is familiar with the gorilla study? Only a couple of you. Okay, so so most of you aren't. So in this study, P.S. I didn't fall for it myself, because part of it was I knew it. So I didn't fall for it. It came out, a version of this came on a TV, and some people started playing basketball, and I was told to count the number of passes, and I was like, ooh, I wonder when the guy in the suit's going to come out. So they didn't fool me. But the idea is the number of throws of the basketball, because you were told to, you won't notice this person in a gorilla suit just walk in the middle of the screen. And that's true, and that's been established. However, everyone misunderstands the conclusion. If something captures your attention, then you pay attention to it. The reason is missed is because people were told to look at the basketball. If you're looking at something remarkable in the sky, you are going to get the details about the correct and the things around you wrong, not the other way around. So this is backwards. Also, eyewitness ability probably falls along a spectrum, just like any human talent. There are some individuals who have neuroeidetic memories and mess this up when, if you've got, where a law professor is teaching his or her class, and someone comes in, it's of course staged, to steal their briefcase. And then the students are asked to stop immediately and describe who did it. And of course, almost everybody's wrong. Key is almost. One wise guy, right? The guy with the photographic memory, who'd be like he was wearing a baseball cap from this team and oranges. So eyewitness testimony is a spectrum. It is true that most of it is not reliable. That is true, but it is still a spectrum. And there is such a thing as trained observers. Law enforcement may not count, but military pilots are trained. They're not going to mistake. They're not going to mistake an object. They're not going to mistake, a commercial airplane or a fighter jet. That's crazy. Here's a little secret. All of science is eyewitness testimony. I mentioned this earlier with Galileo, right? Nobody will tell you that, but it's true. When I publish a scientific paper, someone has to, even when it's peer-reviewed, someone believes me when I said the instrument said that, and I wrote it down. So there's always a level of the human witness. Now, the counter, blah, but you can test it again. Reproducibility. Replicability or reproducibility, these are synonymous. These are some of the cornerstones of science. But because you need balanced skepticism and open-mindedness. Lots of papers get retracted due to reproducibility lacking. And when it comes to UFOs, shapes are taxonomy, and for some reason the shapes are understand this. This is hilarious. So the U.S. government's initial report a couple years ago, when they started, taking UFOs seriously, this is a new thing a couple years ago, right? They had a report. They had an unclassified report. Then one of those FOIA wizards who's like UFO, but all this other stuff, got the classified version, had a lot of black highlighter. One of the things blacked out, pictures of the shapes. And it's like, oh, you got to be kidding me! It's a matter of national security, which is kind of bizarre if you think. So the answers to the replicability problem are, that hasn't stopped us in other places in science. So in astronomy, we only have one universe. We cannot reproduce the Big Bang, not yet at least, right? This does not stop us from doing some great science. If I'm a biologist or zoologist, I can only do so much with animals in a zoo or a lab. Sometimes you got to watch them in the wild, and maybe we're the wildlife in this scenario. But I would never give up on the scientific method, or at least not just yet, because it has served us so well for. Now, is Earth even interesting enough for a non-human intelligence to visit? I'd say yes. What would we do if we discovered a life-bearing planet with an emerging technological civilization? We'd send a probe or something. We would do something. Or another way of looking at it, what about keeping an eye on a violent technological civilization that's not a threat now, but is potentially a danger in the future? That's another perspective. But it's also not always about us. It could be coming for different plants. But intelligent life is maybe not all as common as I claimed originally. Maybe you need a large moon, tidal pools in order to deposit the right amino acids or similar. But, if you think about humans, we study primates. We study a lot of other animals as well that are seemingly less intelligent. So why would that not be true of something above us and more intelligent than us? Wouldn't an intelligence often come, or always maybe come, with some kind of curiosity? So there are no papers, though. Well, this is not so true anymore, but there are very few peer-reviewed scientific publications on this topic. At least in non-crackpot and high-impact journals. But the thing is that there's a circularity argument here. A little more, but this is a cartoon. This is from XKCD, which is where they say the first rule of Tautology Club is the first rule of Tautology Club. So the one issue that is often faced is that you cannot collect data. Why can't you collect data? Because the topic is nonsense. Why is it nonsense? There's no data. Collect data? No, it's nonsense. And see, nobody notices the circularity there. So it's nonsense because there's no data, and there's no data because it's nonsense. So you're not allowed to collect any data. And it's also really hard to prove a negative in science. And so it's not a you're observing something in the sky. It's not a plane, it's not a bird. Or is it a drone? Oh, I forgot that. Or is it a helicopter? Oh, dang, it's another thing. It's really hard. You can never make an exhaustive list to say what something is not. That's an a difficult intellectual challenge. I do have a part 2, but I'm skipping because in the interest of time, I'm going to wrap up because it's been an hour, and hopefully the clouds have cleared. And we can do some observing. So I'm going to fast forward to my conclusions. Here's another quote. I am a fan of quotes. This is from Stanford University biologist Gary Nolan of the Soul Foundation. The data are real. How interpreted is still an open question. So the extraterrestrial hypothesis is like just separate from visitation here. Just in general, the hypothesis that extraterrestrials exist is well justified by data. And there's this, in terms of UFOs, there are decades of claims of sightings of actual beings. Now, critiques of this position, like impossible interstellar travel, are easy. This doesn't explain all UAP. You must have multiple hypotheses, including the prosaic ones. Science in general should be studied, not discarded out of hand if they don't fit into our current paradigm. And so eyewitness testimony counts a zero, shouldn't discount entirely, but it should count more when the radar and the infrared corroborate what the eyewitnesses claim. Even adding up bits, the decades of eyewitnesses is not enough for a solid scientific conclusion. So we absolutely, by no means, we claim, oh yeah, UFOs are aliens, they're ships. No, we don't have that, but we have teasers that suggest that that's a rational hypothesis. Should not just be thrown off the table immediately. We need more data, though. We need better data on class with modern sensors operated by civilian scientists. That way you can get known data provenance like the metadata. And I didn't have time to get into all the crazier stuff, abductions and cattle mutilations, but I think those are separate things, because I think we can quantitatively ask the question, remove all those extra layers, just going back to exoplanets. We can ask the question, is it a rational hypothesis to say that aliens are real? And then second, is it a rational hypothesis to claim that travel from homeworld to here is possible? And I think the answer to both questions is yes, rational hypotheses. They're not proven by any means. They don't even have that much evidence. They have the evidence still not very solid, but it's hinting that it's worth speculative hypotheses. So with that, I will conclude, and I'll be happy to answer questions. Thank you.
So we're back. Your microphone.
Oh, microphone, yeah.
Microphone.
Mm-hmm.
I don't so much as have a question.
Okay.
In the same way that, in light of all this, we're all hoping that a truck along the highway in Canada will hit a Bigfoot and put all the brains out of its misery.
Yeah.
Right. And it's the same as we wish that something would happen, something epic would happen, and again would put us out of our misery. I don't have a question as much as, yeah.
I can respond to your comment. Actually, I had to fast forward through a bunch of slides because I have too much material, as is always the case. No, I don't believe in waiting for something epic, and this is exactly why I am devoting some of my own time to try to collect data, because I'm tired of waiting for it to just appear or the government to say something. I'm all for getting our own data, and so I am not any more interested in waiting for something epic. Some people would say that's already happened. Like there was this gentleman, David Grush, who testified to Congress, says we have crashed ships and we have bodies. But again, I mean, he may be right, he may not be. He's at the level of trust me, bro, right? He didn't come in and plop an alien body in front of Congress. And so I think that people who aren't part of the government working on classified programs need to collect our own data, and not just civilian scientists, but actual scientists at universities with PhDs who can publish papers on it. So I don't want to wait for something to happen on its own. I want to go get the evidence, and that's why I'm a part of several organizations like UAPx. You mentioned that is a group of concerned individuals who want to find the truth, but we don't have an axe to grind. It's not like we're going to prove it's aliens. No, maybe it's because it might not be. I was just suggesting today that's plausible, but not saying that that's what it is. Yeah. But we don't have. We're going into it on the UAPx team in sort of a middle ground between overly skeptical and overly open-minded. Try to thread the needle and just see what the data and the facts say. Microphone. Yeah.
What can we do here to further this gathering of information?
What you can do, I don't know why it exited on its own. What you can do is, if you see something and you can't identify it, don't be afraid of the stigma that, hey, I saw a UFO, and then all your friends are gonna make fun of you. But actually, document, and not just like drawings. Now we've got phones with cameras and stuff. Document anything strange or out of the ordinary. Get the hard evidence. We've all got, now most of us have, smartphones in our pocket that have, cameras that would make, the cameras that they use on the Apollo missions, for example, on the moon, are a joke compared to the incredibly good cameras we now have, like in your cell phone, in your pocket. So I think don't be afraid to document something out of the ordinary and to tell people it happened, because I think that there's a lot of stigma and taboo against this topic. Like the military pilots I mentioned who reported having strange encounters, they get back to the ship and they've got, like, in their quarters, like in the room, people have put up, the posters of aliens and stuff like that to document what happens to you, especially if you're an astronomer or an amateur astronomer. You see something weird and it's not behaving like a satellite and it's not a star or planet. Gather the evidence and document that it happened, and don't be afraid to tell people that this happened.
Hi, Doctor. I really enjoyed your talk. Amongst the science world about dimensions, interdimensional travel, that sort of thing.
So yeah, I had a slide on that earlier and I skipped over it, but that's a good question. It's because in the interest of time, I wanted to focus on the extraterrestrial hypothesis. But you bring up a good question. I'm not discounting that possibility, but there's zero evidence in favor of that idea right now. That doesn't mean it's not real. It's just that I'll give you some examples that will tie into astronomy, actually, why we're here, tonight in this observatory. Here's an example. So I can't get into the esoteric mathematics of it, of course, in this short time. But the fact that gravity, like Newton's law of gravity, goes down as 1 over r to the second power, 1 over r squared, and electricity as well, that proves that the world is 3 dimensions, that particle colliders like the LHC. Now, if you're talking about parallel universes, that's a separate thing from extra dimensions. They're often conflated in fiction, but that's a separate thing. So an extra dimension is just another direction in which to move. Like, let's say we all lived in flatland, then we'd have no words for what is for up and down, no comprehension of that. But then there's also the idea of parallel universes. There's a universe where Germany won World War II and this other thing happened. So that's a separate concept where you have other universes with their own sets of dimensions. All those ideas are much more speculative even than the extraterrestrial concept, because we don't have any evidence of those things despite looking for many years. So again, that doesn't mean they're not real. We just don't have even a single shred of evidence in favor of either extra dimensions or a parallel universes, or both. But thank you for your question. Yeah. Some questions in the back also.
Are there?
Yeah.
Go ahead, John.
Oh, okay.
Yeah.
I think it's often the distances involved, and I know you addressed that earlier. Can't say 50 years. You're talking about 50 years that pass on Earth.
No,
But
on the craft, the occupant.
but okay. Because you're traveling at the
You're traveling close to the speed of light.
and then time.
Yeah.
Okay.
Yeah, so
I see.
Yeah, if I'm in a craft,
Yes.
and I go, no warp drive involved, no faster than light involved. So the speed of light is 299,792,458 meters per second. If I were to travel, again, we don't have the technology to do that, I'm not claiming that. If I were to go 299,792,457.9 meters per second. So 0.1 meters per second slower than the speed of light. And I started from Earth today, I would reach the Andromeda Galaxy in 50 years experienced by me. On Earth, 2 million years will have elapsed, but not for me. It's like the twin effect from relativity. Right. And this is extremely well established scientifically because if you didn't account for relativistic effects, GPS wouldn't work, for example. You have to account for the fact that the satellites don't go near the speed of light, but still they're going 17,000 miles an hour or something that's close to that. And so you do have to account for relativistic effects. So we know this is real. We just don't have the technology to do it on such scales. But what's remarkable is at the velocities that are written about by my colleague Kevin Knuth in the scientific paper he published about the Nimitz UFO encounter. At the not velocities, like the accelerations that were measured by Kevin and his co-authors, if that could be sustained in space, the Tic Tac could cross the entire Milky Way galaxy in a few months. Now, of course, that doesn't mean a few months go by on Earth or in the galactic rest frame. But the point there I was making is time dilation. Time dilation works in your favor. And length contraction. So in the Andromeda example, if you are flying at that speed towards Andromeda, from your perspective, Andromeda is only 50 light years away, not 2 million. So the length is not literally contracting. It's not space-time warping like we talk about in general relativity. But nevertheless, the length that you would measure if you're the occupant of a ship traveling near the speed of light, to you, everything is close by. It's not millions of light years away to the next galaxy. And again, none of that is hypothetical or speculative. All of that is hard science we've known since 1905.
Okay.
Yeah. I hope that addresses your question. Yeah.
Yeah. Any?
Back. Yeah.
Michael, thank you for your presentation. It was wonderful, extremely informative.
Oh, hang on. I will get you after we get this question. Yeah.
Oh.
Yeah.
As the observatory director, I grant you the microphone.
Okay. Yeah.
One of the points you made.
Yeah.
One of the points that you made earlier was that we're aware of thousands, tens of thousands of exoplanets.
Correct.
And you said that a large portion of them would be habitable.
Yes.
I presume it's because they're within the habitable zone of the stars that they're going
Correct.
around, and the stars are not too active and nasty ways. But do we have a way of knowing whether they have an oxygen-rich atmosphere?
Not yet, but we're working on that. So like with James Webb Space Telescope and with future missions, we're actually going to be doing chemical spectroscopy on the different atmospheres. But you're right that we have to be careful that just because something is in the habitable zone doesn't mean it's habitable, and that might be what we're getting at. Let's say if I was an alien astronomer, if I was looking at our system, I would never guess Earth is habitable. Never. I'd say, oh, it's Venus. Send signals towards Venus. Because Earth is too cold. The reason why Earth is habitable is because actually, and I'm not talking about human-driven climate change. Before humans, there's a natural amount of CO2 in the atmosphere. If we didn't have that, the average temperature, negative 20 degrees Celsius. So if I was an alien astronomer and I knew nothing about the atmospheres, which is the situation humans are in, I would look and I'd say, oh, it's got to be Venus. Earth is cold. That's impossible. How can Earth be habitable? But your question then brings forth this really important point that we have to be careful about what we say is habitable. But what's really remarkable is even if I was wrong by some huge amount, which we probably are, there's still, let's say that the habitable world, there are only a few billion. That's a massive number still. So even if we're wrong about the habitable zone, we have to be wrong by many orders of magnitude to say that we're alone in the galaxy.
Well, I suppose it's possible for a biological system to develop that's not dependent on oxygen.
That's right.
I mean, we
That's
certainly
right.
have those in the deep sea.
That's right. So there are, when we talk about the habitable zone, we're specifically enforcing human habitability. So it goes actually both directions. The habitable percentage could be lower, much, much lower, because you point out you not necessarily have the right stuff just because you're in the zone. You might not have liquid water, you might not have oxygen, but it could go the other way too, which is life that doesn't need any of that stuff. It operates on something else. Maybe there's, fish on, one of the moons of Saturn that swims in liquid methane, right? It could be, even in our own system. So I think it can cut both ways. That number could either be substantially higher or it could be lower.
Thank you. Sure. Thanks a lot.
You're welcome.
Are they, chemically, you're going to search exoplanets for oxygen. Are we able to detect magnetic fields? Because that's vital for our existence.
No, not at this distance. No, that is not possible.
I mean, there is no...
There's no way. No. You can't. Also, depending on the nature of the magnetic field, so if you have a magnetic dipole field, like the Earth, if you have a dipole field, that drops off as the distance cubed, not the distance squared. You are not going to measure magnetic or electric fields for that matter. But one thing we might be able to do, and again, James Webb Space Telescope is this is one of the possible things that could happen, is maybe we would see, the city lights of a distant alien civilization. That's possible with the resolution that we have, but we cannot sense electric or magnetic fields. But you're right that that's another crucial element of habitability, and it's often overlooked. And it's because without that, if you don't have the protection of magnetic field, then you might have so much mutation that life cannot actually evolve in a positive way, and just all creatures get cancer and die, right? Just mass extinction. So that is a good point, is magnetic field might be a crucial element, but we have no ability to tell that from a distance. And that's and we're never going to anytime soon. That's a very, very hard thing, but that's a great question. But there was a question in the back also, I think.
Thank you. When you said that the UAPx and you're going to be focusing your self-research going after this, what are the technologies that you're using, or what are the most valuable technologies that perhaps the community could use to help support the data that you're looking for?
So we want to go. Oh, for some reason it shrank again. we want to go all out and use not just cameras that record visible light. We want to do, but it's really hard to get a huge effort going because all this stuff is expensive, unfortunately. But we want to do infrared and ultraviolet, just like how we've discovered so much about the Milky Way galaxy when we went out from just optical, and we studied it in microwave, infrared, X-ray, gamma ray. So we want to expand to other parts of the spectrum, because nobody wants another blurry UFO picture that people would say, oh, that can be anything, So how do you combat that is a multispectral approach. And not just with light, not just electromagnetic radiation, but other kinds of radiation. There are claims that aren't even that crazy. So the late Senator John McCain helped a veteran get disability insurance for his claim that he had radiation burns from a UFO, and that sounds laughable. He got disability, and he was fighting for decades because everybody laughed at him. Senator John McCain, actually, before he died, went to bat for the guy, and he got his disability insurance with claiming to get radiation burns from a UFO. So what kind of radiation? So we want to look at also ionizing radiation, alpha, beta, gamma, neutron, things like that, and be like, and study the possibilities. Okay, let's say there is some advanced technology in the sky. What if it's got some advanced nuclear power, something or other? Is there a side effect of that? So on UAPx, our approach is to, but again, it's hard because it's expensive. We want to gather as many different types of sensors as possible. And the other key is is multiple. If all you have is cameras, that can still be valuable, because you want to have multiple cameras that spot the same object from different angles. Because then, if the cameras, there's caveats, like cameras got to be far enough apart and things like that, and you have to know the properties of the cameras enough, but you could start to do some triangulation, determine where is the object, how fast is it going, because you can't do that with one image. And this happens all the time, and this is why some of the stigma in the UFO field is rightfully so, because it always drives me nuts when someone's got a picture of something that's like, oh my God, look, it's 300 feet across. How do you know that? How do you know it's not a speck right in front of you? Distance and size are degenerate. How do you break that mathematical degeneracy? Is you need at least 2 vantage points, or more is ideal, of course. But at least 2, you start to be able to narrow the parameter space to be able to estimate things like distance, size, velocity, acceleration. So multiple sensors is the key, and multiple cameras from different angles to capture things. Question up here, can we pass the microphone up to the front row?
How reliable is the spatial relativity other than GPS satellites? Are there any other evidence that spatial relativity is correct? Because I'm thinking that the satellites, GPS, it is orbiting the Earth, and there could be like a lot of errors in terms of like there are like cosmic rays and those things, radiations. So it could affect the atomic clock there, and then also location can be like not accurate. So they would rather think than keep correcting those spatial relativity terms. So do you have first-hand knowledge that they are using the spatial relativity to correct the speed? And is there any other evidence that spatial relativity is correct?
Yes, there's over 100 years of evidence. It's one of the relativity is one of the most validated scientific theories in the history of humanity. It has more evidence than the theory of evolution and atomic theory. So here's an example. So in the 1970s, we flew 2 planes around the world in opposite directions with atomic clocks. And the result was exactly the difference predicted by relativity. In your example with GPS satellites, that would be a magical coincidence that the so-called errors from cosmic rays just magically exactly match the predictions of relativity. Yet another example is cosmic ray muons. This was the first proof of relativity over 100 years ago, was that there are these cousins of electrons called the muon particle. They're traveling close to the speed of light. Most of them should not make it to the ground because they're radioactive and they decay. But a much larger number makes it to the surface of the Earth than expected. And it's exactly the number predicted by relativity. Then there's the solar eclipse in 1919, then there's gravitational lensing, then there's the fact that your phone works in your pocket. It's not just quantum mechanics, it also needs relativity because the electrons can go fast in circuits. I could literally go on for 3 hours about the mountains of evidence for relativity.
But one evidence about GPS, are they then not sync or reset anytime? Are they going on like years without resyncing?
No, you have to constantly resync because of relativity. There are 2 effects. So not only are satellites going fast, they're also farther from the center of the Earth. So the speed makes time slow down, but also the distance from the center of the Earth makes time speed up. You have to sum those 2 effects together. If you didn't do that, then in a couple weeks your GPS would stay in the middle of the ocean. So relativistic effects are not an optional correction for GPS.
Let me ask 2 questions.
Okay.
Then do you have first-hand knowledge that they are using spatial relativity equation in there? Do you have first-hand knowledge, or did you just hear that they are using it?
I assign homework problems where my students calculate the GPS correction.
But you don't have the
No, I don't have first-hand knowledge, but I also don't have first-hand knowledge of quarks. Nobody's ever seen a quark. I don't have first-hand knowledge of the pictures of the atom from the 1980s. But if we require first-hand knowledge of everything, then we have to throw out all of science. I can't go and redo everybody's work. I can't redo every scientific project around the world. I have to accept what other people say? Like that this otherwise, like I don't understand.
So we
Yeah.
don't have the first-hand way of verifying that the GPS satellites are using the special relativity to correct. We cannot.
I don't personally, but I don't need it. I mean, you don't have firsthand knowledge the President of the United States exists. You just saw him on TV, which is just electrons on a screen. But do you have firsthand knowledge of electrons in your phone? You don't. Do you have firsthand knowledge of the electrons traveling through your smartphone in your pocket?
Okay,
You don't.
That's correct. And
Yeah, see, that's my point.
Another
Yeah.
point is how often GPS satellites resync or reset. How often do they do that?
I don't know that. But that doesn't mean they don't use relativity. They have to use relativity. It doesn't make sense. Like, I don't know what to tell you. Like, we have 100 years of science that says it's correct. Gravitational waves. I mean, I could go on and on, but I don't have firsthand knowledge of any of those things because other people have to report things. You don't have firsthand knowledge that I live in a state. You have no proof that state exists unless you go there. Right? You have no proof that I don't understand what to say. I don't know what to say. I mean, germs. You've never seen a germ unless you've done it in biology lab, and germs will still hurt you even though you might not believe they exist, and they're too small to see with the human eye.
So what we have is trust us rather than we can.
No.
The details.
No, we have reproducibility. The scientific community all works together to cross-check other results so that bad results are removed from the scientific community when they're not reproduced.
We didn't go line by line.
But that's impossible. How can I go line by line to all of science? That's impossible.
But the special relativity,
I teach special relativity. That I've gone line by line with. I teach it. I teach it, and I give my students the assignment of the GPS correction.
Can I ask you one more question?
Last question. All right, yeah.
E equal mc squared.
Yeah?
How much is energy? How much is neutrino? Percentage-wise, there must be some kind of table for each, like fission or fusion reaction.
Yeah?
E equal mc squared. Mass will be missing. Not matter is missing.
But
mass is missing, but energy and then neutrino. How much percent are each? You are doing
for the neutrino?
neutrino.
Neutrinos are almost massless, so they're mostly energy. But actually, I'm really glad you brought that up. More evidence that relativity works. And but I guess I have to trust the people who told me we dropped an atomic bomb and it worked. The atomic bomb wouldn't work without special relativity. It's impossible. E equals mc squared is part of relativity. That's part of relativity.
Yeah, but it doesn't require E equal mc squared.
It does. The atomic bomb would not work without E equals mc squared because you're converting matter into energy. So like I didn't do it firsthand. I didn't witness the A-bomb firsthand. But I heard we made atomic bombs and they don't work without relativity. Einstein, in fact, regretted telling President Roosevelt about relativity.
E equal mc squared is just the quantity, not the concept that mass is converted to.
We convert mass to energy every day. We do it in particle colliders.
Do you know how much percent is?
The percentage depends on how fast you're going. E equals mc squared is actually what everybody memorizes is only part of it. The full equation is E squared is equal to mc squared squared plus p squared c squared. You have to account for momentum and energy. And so you're asking an impossible question because the percentage ratio depends how fast you're going. The faster you're going, the more energy is in kinetic energy versus mass energy.
I have a final question.
Absolute final question. I want to respect Michael's time, but it's clear I
Matthew.
want to do some-
No, yeah.
Yes.
Yeah.
If we can.
Yeah.
A real quick one for you. and
Sure.
It's just a personal thing for you.
Sure.
Basically, do you think, based on the results of Webb, do you think the huge giant Magellan and the 30-meter will compete?
That's an excellent question. I think it can still compete, and the reason is because of adaptive optics. So we have the technology to basically cancel atmospheric effects, like the twinkling of stars. And I think that will enable ground-based telescopes to compete for the first time. I'm not saying it'll be, I don't know enough I don't know enough numbers and facts about the telescopes to compare them directly, but I believe they'll at least be similar. Because again, the adaptive optics is a real game changer where we no longer have to go to outer space. It's still better, but ground-based telescopes are at least similar now, can now compete thanks to adaptive optics. So I look forward to see what the GMT will be able to produce. It's definitely easier to repair. Right, something goes wrong with James Webb, like did with Hubble, we've got a big problem. But GMT, it's in the desert in Arizona, and go fix it. So there's just pluses and minuses of ground and space. But that's a great question. I look forward to see what the GMT will show us about the universe in the near future.
Excellent.
All right, thank you.